Wow, look at that huge wave crash. It just splashed right over my toes. Hey, Dr. Owl, did this exact water travel all the way across the entire ocean just to splash my feet?
That is a fantastic question, Emma. It looks like the water is rushing toward us, but the truth is, it is doing something completely different.
Beep, boop. I am making a wave. Look at me. I am doing a belly flop into this kiddie pool. Science-tastic. Wait, I just emptied all the water out.
Oh, Ziggy, you certainly moved the water, but ocean waves are usually formed a bit more gracefully. In fact, we have two amazing explorers, Vikram and Raghav, who are both 4 years old, and they asked the exact same question. They want to know, how are waves formed in the ocean?
Oh, I want to know too. Let's dive in and figure it out.
Booting system, curiosity, on, logic, on, chicken dance protocol, stuck on. Book, God!
Ziggy, wrong button. Stop the clucking.
Hoot hoot! I suppose we're doing science and dancing today. Welcome to STEM with Dr. Owl. Here we explore how the world works.
With curiosity.
Protocol 404. If this show is fun, tell a friend. If it's not, it must be a software bug. Literally, there is a ladybug on my enter key.
Welcome back, explorers. Before the break, Emma and our friends Vikram and Raghav asked a wonderful question about where ocean waves come from.
Right. Because if the water isn't traveling across the ocean to get to the beach, what is happening?
Processing. Oh, is it giant sea monster sneezing? Achoo splash.
Not quite, Ziggy. To understand waves, we need to do a little experiment. Ziggy, since you refilled your kiddie pool, let's use it. Emma, I want you to just blow across the surface of the water.
Okay, here goes. Oh, little tiny ripples are forming.
Exactly. Out in the real ocean, those little ripples are created by the wind. As the wind keeps blowing and rubbing against the surface of the water, it transfers its energy into the ocean, making those ripples grow into bigger waves.
So, wind makes the waves? That means stronger wind makes bigger waves.
Warning. Mega wind initiated. I turned on my built-in hyper fan. Look at those waves.
Yes, Ziggy. That is a very wet demonstration. Now, let's test our explorers' listening skills with our very first trivia question.
Ooh, I love trivia. Listen closely, everyone.
Here is the question. What invisible force creates most of the ordinary waves we see in the ocean? Is it A, fish swimming really fast? B, the wind blowing across the water? Or C, Ziggy's belly flops?
Oh, it has to be C.
No way, Ziggy. The answer is B, the wind.
Spot on, Emma. The wind pushes against the ocean surface. Now, here is the really tricky part. The wind is transferring energy into the water, but it is not taking the water on a road trip.
Wait, what do you mean by energy? Doesn't the water move forward when the wave moves forward?
It looks that way, but let's use our imagination. Have you ever been to a sports stadium and seen the crowd do a stadium wave?
Oh, yes! Everyone stands up and throws their hands in the air, and then they sit back down, and the next person does it. The wave goes all the way around the whole stadium.
Exactly. But did the people move around the stadium?
No, they just stood up and sat back down in their own seats. Oh, I get it. The wave shape moved, but the people stayed in their spots.
Brilliant deduction, Emma. Ocean waves work exactly the same way. The water particles move up and down in little circles as the energy passes through them, but the water mostly stays right where it started.
Beep boop, analyzing. If I put my favorite rubber ducky in the water and a wave goes by, the ducky will just go up and forward a tiny bit and down and back. It does a little loop-de-loop.
That is a perfect way to think about it, Ziggy. The energy travels, not the water.
Precisely. And because the energy can travel very far, waves can keep moving long after the wind stops blowing. These smooth, organized waves are called a swell. Let's spell that so we remember it. S-W-E-L-L. Swell.
Swell. So that is why there can be waves crashing on the beach even on a totally sunny, calm day with no wind? The energy traveled from a storm far away.
You are absolutely right. Which brings us to our second trivia game, a quick game of true or false.
I am ready.
True or false? The water splashing on your feet at the beach today traveled thousands of miles across the ocean just to say hello to your toes.
False, false. The energy traveled, but the water was already hanging out near the beach. Ha ha ha.
Ziggy got it right. It is false.
Excellent job, both of you. Now, there is one last mystery to solve. If the water is just bobbing up and down in circles, why do waves suddenly stand up tall and crash over when they reach the shore?
Does it have something to do with the bottom of the ocean? Like the water gets shallower near the beach?
That is exactly the reason. Out in the deep ocean, the wave energy reaches deep down underwater. But as the wave travels closer to the shore, the water gets shallow, and the bottom part of the wave starts dragging along the sandy seafloor. This creates friction, which is a big word that just means things rubbing together and slowing down.
Oh, so the bottom of the wave slows down because it is rubbing against the sand.
Yes, the bottom slows down, but the top part of the wave keeps moving fast. Because the top is going faster than the bottom, the wave gets steeper and steeper until it loses its balance and...
Crash. It tumbles forward, like when my tank treads get stuck on a rug and my top half keeps going. Whoops.
Oh, Ziggy, be careful. But that makes total sense. The beach actually forces the wave to trip and fall over. And that is the crashing wave we see.
Exactly. And just as a quick fun fact, not all waves are made by wind. The daily tides that slowly move up and down the beach are actually caused by the gravity of the moon and the sun pulling on the earth. And giant waves called tsunamis are usually caused by underwater earthquakes. But most of the fun, splashy waves we see every day are born from the wind.
This is so cool. We learned that wind pushes the water to start a wave, but it is actually energy traveling through the ocean, not the water itself. And then the wave trips over the shallow seafloor and crashes.
You summarized it perfectly, Emma. I hope that answers your question, Vikram and Raghav. Keep being curious, explorers.
Beep boop. Hey, Emma. If wind makes waves, I'm going to generate the ultimate surfing wave right here. I just set my internal cooling fan to hurricane mode.
Wait, Ziggy, we do not even have any water in the studio.
The wind is pushing me backward. I am traveling just like a swell.
And that brings today's STEM adventure to a close. Remember, the world is full of wonders if you just know where to look.
Thanks for exploring with us. Don't forget to keep asking why.
Preparing shutdown sequence. Deleting. Browsing history. Deleting. Emma's math homework.
Ziggy, no! Don't delete that!
Just kidding. Robot humor. Curiosity stays on battery level 1%. Oh, almost forgot. If you have a question, leave it in the comments. My inbox is lonelier than a robot in a rainstorm.